You know this one, the derivative of x cubed, is 3x squared. Now let's reverse it. If I give you 3x squared, can you find the function that produced it? That's exactly what integration does. Suppose the derivative of x cubed equals 3x squared. So if we ask, what is the integral of 3x squared dx? We are asking what function differentiates to 3x squared. The answer is x cubed. Because the derivative of x cubed equals 3x squared, so integration is, in this sense, reverse differentiation. Let's test it. Evaluate the integral of 8x cubed dx. Don't think of this as a completely new operation. Think, what differentiates to 8x cubed? We need a power of 4, because differentiation reduces the power by 1. So start with x to the 4th. Differentiate. The derivative of x to the 4th is 4x cubed, but we need 8x cubed. So multiply by 2. The derivative of 2x to the 4th is 8x cubed. Therefore, the integral of 8x cubed dx equals 2x to the 4th plus c. And notice what just happened. The power went from 3 to 4, and then we divided by the new power. 8 divided by 4 is 2. That's the power rule you learned earlier. Now you know why it works. But wait, is 2x to the 4th plus 5 also correct? Let's differentiate it. What about 2x to the 4th minus 100? Differentiate 8x cubed. Again, the constant disappears when differentiated. So there isn't just one answer, there are infinitely many. They all have the same derivative. That's why we write 2x to the 4th plus c. The c represents any constant. So when you're finding an indefinite integral, don't just ask, what is the answer? Ask, what function has this derivative? Now let's make it slightly harder. Evaluate the integral of 6x squared minus 4x plus 7 dx. Work backwards, term by term. For 6x squared, increase the power, 2 plus 1 is 3, then divide by 3. 6x cubed over 3 is 2x cubed. Next, minus 4x. Increase the power from 1 to 2, then divide by 2, minus 2x squared. Finally, 7. What differentiates to 7? 7x, because the derivative of 7x is 7. Put everything together. Now let's do something good students should get into the habit of doing. Differentiate your answer. Differentiate 6x squared minus 4x plus 7 plus 0. So 6x squared minus 4x plus 7. That's exactly the original integrand. Correct. Integration and differentiation can check each other. Now let's see whether you can use the idea without me giving you every step. Evaluate the integral of 5x to the 4th minus 6 over x squared plus 3 dx. First, rewrite the fraction. 6 over x squared is 6x to the minus 2. For the first term, 5x to the 4th, increase the power, 4 plus 1 is 5, and divide by 5, x to the 5th. For the second, minus 6x to the minus 2, increase the power, minus 2 plus 1 is minus 1, then divide by minus 1, 6 over x. And the integral of 3 dx is 3x. Therefore, x to the 5th plus 6 over x plus 3x plus c. But there's one thing you must remember, the ordinary power rule. It does not work when the exponent is minus 1. Why? Because adding 1 gives 0, and we cannot divide by 0. So the integral of x to the minus 1 dx has a special result. Natural log of the absolute value of x plus c. Therefore, the integral of 1 over x dx equals natural log of the absolute value of x plus c. You will use this repeatedly as integration gets harder. One last question. Don't calculate it mechanically, think backwards. Evaluate the integral of 4x cubed plus 6x squared minus 2x plus 5 dx. What function would produce this when differentiated? Start. 4x cubed becomes x to the fourth, because the derivative of x to the fourth is 4x cubed. 6x squared becomes 2x cubed. Minus 2x becomes minus x squared. And 5 becomes 5x. Therefore, x to the fourth plus 2x cubed minus x squared plus 5x plus c. Now differentiate it. 4x cubed plus 6x squared minus 2x plus 5. It matches. That's integration. So remember the idea, not just the formula. Differentiation moves forward. Integration works backward. When you see the integral of f of x dx, ask yourself, what function differentiates to f of x? Then use the rules you've already learned to find it. Next, we are going to use this idea on a completely different type of integral, one where the power rule alone doesn't work. That's where substitution begins.